All right. So let's go ahead and do a couple of practice problems. These practice problems are pretty much intended for a couple of review since weren't able to have class because I have COVID right now. But so if I do take a moment to pause and cough, you'll have to excuse me. All right. So let's go ahead and do a couple of problems. And all these problems are directly from the study guide that I posted on the Blackboard. So for this first one, solve for x. So solving for x, let's go ahead and see what we're dealing with here. Here we have an exponential equation. E to the 3x is equal to e to the x minus 3. So the first thing we want to deal with an exponential equation is seeing, can I make the bases match each other? So for this problem, what's the base on the left and the base on the right? Well, the base on the left and right, in this case, they both turn out to be e. So that's great for us. Since the bases match, then it must be that I can set the exponents equal to each other. So in this case, I have 3x is equal to x minus 3. So from here, we've actually already done the hard work. Now we're just solving a linear equation. So how do I solve for x from here? So what I would probably do is, let's start off by subtracting x from the left and right. So if I do that on the left, 3x minus x, I get 2x equal to, and I still have a negative 3 here. Now I have 2x is equal to negative 3. How do I solve for this? Well, I can now go ahead and divide by 2 on the left and right, because again, I want my x to be alone. And this gives me x is equal to negative 3 over 2. And this definitely doesn't simplify any further, telling me I have my final answer. Great, so we have this here. Let's do a couple more examples with exponential equations. What if I look at 25 to the negative x is equal to 5? So again, I have an exponential equation, and somehow I want to make the bases match. So it's not like the previous one where the bases already started off matching from the beginning. In this case, I have to do some realignment. So let's look at 25 and 5. How do I make these bases match each other? Well, there's not much we can do with 5, but 25, I can definitely do something with that. I know that 25 is the same thing as 5 squared. So all I changed here was that 25 is the same thing as 5 squared. So, and just for convenience, I went ahead and wrote that 5 is the same thing as 5 to the 1 power. A little trivial, but it will help us. So now let's continue cleaning this up. On the left, I don't want to have 5 squared to the negative x. To combine this, I'm going to do 2 times negative x, giving me 5 to the negative 2x is equal to 5 to the 1 power. Now, let's go ahead and combine these. Well, not combine, but clean this up further. By doing this, I now have the same base on the left and the right. I have a base of 5 here on the left, base of 5 here on the right. Therefore, I can set the exponents equal to each other. That is, I can write negative 2x, this left exponent, is equal to the right exponent, 1. And this is also why I went ahead and wrote 5 to the 1 power, just so that we know that it's going to be a 1 on the right. So I'm going ahead and continuing by, let's go ahead and divide by negative 2 to solve for x, giving me x is negative 1/2. And clearly, negative 1/2 is not going to simplify, giving us our final answer. Perfect. So we've done 2 exponential equation examples. Now let's go ahead and talk about the other parts of this chapter, logarithms. Here, same instructions, solve for x. Here I have log base 27 of x is equal to 2/3. All right, so how do I even solve this? Remember, in class, we did an example where I can always jump back and forth between log form and exponential form. And one way we talked about this is the base of my logarithm is the base of my exponential. So I just read this as log base 27. So my base is 27. And now using this, I can rewrite this into exponential form. So we have a base of 27 to what power? Well, we have 27 to the 2/3 power is equal to x. And we're almost essentially done here because x is alone. All I can really do from here is let's simplify 27 to the 2/3 power x. You can do this by hand or via calculator. I believe we should be getting x is equal to 9. So really, this example was from our notes, seeing how do I convert back and forth between exponential and log form. Let's just do another practice example with that. Same instructions, solve for x. Once again, I have log base 3 of 7x is equal to 3. So how do I deal with this here? Well, what is the base of this logarithm? Well, the base is 3. Therefore, I can rewrite this as 3, base 3, to the 3rd power is equal to 7x. So it almost looks like after I identified my base, I did sort of this crisscross action in a sense. So now that I have this, let's just clean up 3 cubed. 3 cubed, that's 27. And then how do I get x alone? Well, if I want to go ahead and get x by itself, let's go ahead and divide the left and right by 27. And I just noticed a typo here. Let me fix that real quick before we can look at that. You'll have to excuse me. Let's see if I can fix that behind the scenes. All right, so let's go back to that. 3 cubed is equal to 7x, 27 equal to 7x. So let's divide by 7 on the left and right. If I divide by 7 on the left and right, 27 over 7, there's not much I can do there. On the right, 7 divided by 7 cancels each other out, leaving me with x, giving me my final answer. So for this example and the previous one, the big thing we need to know is how do I go from this first line to the second line? Because after I do that, it's pretty much just solving a linear equation. So great. Now we have 2 examples of exponential equations, 2 examples of log equations. Now let's go ahead and look at the last 2 types that we talked about in this chapter, expansion and condensing. So my instructions here are expand this logarithm. I have ln of 7x to the 5th y over 3z to the 4th power. So what can I do here? Well, I know in expansion, I know if I have multiplication on the inside, it becomes addition if I separate them. So let's focus on this top half. On the top, I have 7 times x to the 5th times y. Therefore, this becomes the natural log of the first part plus the natural log of the second part plus the natural log of the third part, sorry. What about the bottom? Well, this is being divided on the bottom. So instead of having pluses, these should have minuses if I think about my quotient difference law. So remember, that means if I have a quotient, things on the bottom, that comes with a minus whenever I separate them. So in this case, I have minus the natural log of 3 minus the natural log of z to the 4th. In other words, if I give you something like this, if it's on top, where it's being adding the natural logs, if it's on the bottom, it's subtracting the natural logs. So what else can I even do from here? I've expanded it quite a bit, but there's one more thing I can do. I've used my product sum law, my difference quotient law. The only one we haven't really used is my power coefficient law, which says that if I have a power or an exponent, whatever you want to call it, I can move it to the front of that logarithm. So here I have x to the 5th. I can move this power of 5 to the front of this logarithm. And the same thing for the z to the 4th. I can move this 4 to the front of this logarithm. In other words, I should get natural log of 7, didn't change anything there, plus 5 natural log of x, plus the natural log of y, minus the natural log of 3, minus 4 natural log of z. So all I did was move the powers. All right, so I've applied all 3 of my rules, which is going to be a nice indicator telling me, all right, I'm finished. So this is our complete expansion. Now, let's go ahead and do one last example. We expand it. What about condensing? So, natural log of 15 plus 5 natural log of x minus 5 natural log of y. So for condensing, we're going to go a little bit in the opposite direction. Remember, for expanding, we did product sum and a quotient difference. And then we did the coefficient power rule. So for condensing, we're going to go in the reverse. Let's get rid of these coefficients first off. Here I have a coefficient of 5, and here I have a coefficient of 5. This tells me I can move the coefficient to the power within the logarithms. So natural log of 15, I didn't change anything. For this one, I moved the 5 into the power, and I moved this 5 into the power for y as well. All right, so I applied my coefficient power law. Now I can apply my, let's focus on these first two. If I have separate sums, I can combine them by multiplying. In other words, for this first half, I can write this as natural log of 15 times x to the 5th. And I haven't touched this right side yet. So this is my product sum law. Next is now I have natural log minus natural log. What happens whenever we subtract them? Subtraction, well, becomes division. In other words, I can combine these two natural logs to give me natural log of 15x to the 5th divided by y to the 5th. And now looking at this, I've condensed it down to a single logarithm, telling me, all right, I'm done. All right, so these were a couple of quick examples. I went through them very quickly, but this is a good coverage of our most recent chapter. If you've made it this far, I do recommend that you look at those particular questions I posted in the email for our final exam. As usual, if you have any questions, feel free to send me an email, and then we can talk about it. Besides that, Miss Gina Gallup will be proctoring your exam tomorrow, but good luck on your exam.